Okay, so now we're going to do the next part of this problem. And in the last section, part A, we just found that our acceleration was about negative 6.4 meters per second squared. And so, looking at part B, we have a new question that's being asked of us. If Bambi's 92 meters away when he hits the brakes, will Bambi get smushed? So really the question here is asking, how far will the car travel before it comes to a stop? If it travels more than 92 meters, we have a dead Bambi. If it travels less than 92 meters, we'll have a living Bambi. So nothing changes about the graphs or the knowns and unknowns, except that now I also have my acceleration known, and I have a new unknown here. So then moving forward, now I'm looking for an equation that will solve for delta x when given initial velocity, final velocity, time, and acceleration. And there are really several equations you could use for this, but the one that I choose to use is delta x equals 1/2 at squared plus v initial t. This is just the most straightforward and fastest equation to use for this process. So now I can start plugging values in, and what we'll get is delta x equals 1/2 times negative 6.4 meters per second squared times t, 7 seconds, squared. It's important that that squared is outside of the parentheses, plus v initial, 45 meters per second, times t, 7 seconds. Going in and working this down further, we get 7 squared is 49 times negative 6.4 is 49 times 6.4, 313.6. Divided that by 2, we get delta x equals negative 156.8 meters, because my seconds squared. My seconds are squared, and then that squared seconds cancels with the squared seconds. And then for the second term, we have 45 times 7, and that's positive 315 meters. Again, my seconds cancel with seconds, and I'm left with meters. So adding those things together, we get a total of, what, 159.8. Right? 315 minus 156.8. 158.2, sorry. Meters. And since that's greater than the 92 meters that Jared has before hitting Bambi, that means that we will have a dead Bambi.